Hey, so your mail order company advertises that it ships 90% of its orders within 3 working days. So they're proposing that their population proportion, right? So their population proportion is 0.90, right? Um, you select an SRS of 100. So our sample size that we're taking 100 orders, okay? And then of the 5,000 orders received in the past week for an audit, so the population size is 5,000. Okay. The audit reveals that 86 of the orders were shipped on time. Okay, so 86 out of the 100 were shipped on time. If the company really ships 90% of its orders on time, what is the probability that the proportion in an SRS of 100 orders is as small as the proportion in your sample or smaller? Follow the 4-step process. Okay, so they're wanting to figure out, they want to find, so in part A, they want to find the probability that our sample proportion, right, is less than or equal to 86 out of 100, right? Or, of course, we could write this as the probability that our sample proportion is less than or equal to 0.86. So that's what they're looking for. Okay, so equals question mark. All right, so let's go ahead and start our 4-step process. Let's do our state. Okay, so we want to find uh, the probability that p hat is at most 86%. Okay, so let's go ahead and start our plan. So, like with these problems, our plan is always to establish that p hat is approximately normal with the mean of p hat and the standard deviation of p hat, right? Okay, so we know the mu of p hat is just the population proportion, which was given to us as 0.90. And remember, for the standard deviation, we have to do the 10% condition first before finding it. So 10% condition. So this states that n must be less than or equal to a tenth of big N, right? So remember, n was 100 and big N was 5,000, right? Well, I know that a tenth of 5,000 is 500, and 500 is definitely bigger than or equal to 100. So our 10% condition does hold. So this means that the standard deviation of p hat is equal to the square root of p times 1 minus p all over our n. And this is the square root of zero point 0.9 times zero point 0.1 over 100. And if you do this calculation, you'll approximately get 0.03. All right, so we have our standard deviation of p hat and we have our mean of p hat. Now we have to determine if p hat is actually approximately normally distributed, right? Okay, so check normal condition. Okay, so remember the normal condition is n times p has to be bigger than or equal to 10, and um, n times 1 minus p has to be bigger than or equal to 10. So let's do this one first. So n was 100 and p was 0.9, and that's equal to 90, and 90 is bigger than or equal to 10. Okay, so that checks. So let's go ahead and do the next one. So 100 times 0.1 is equal to 10, and 10 is definitely greater than or equal to 10, right? So that checks. So since our normal condition does hold, this implies that p hat is approximately normal with mean of 0.9 and standard deviation of 0. What was it again? 0.03, right? All right, so now that we have this, we can do our calculation relatively easily. So the probability that p hat is less than or equal to 0.86 is equal to the probability that, so now we know that p is approximately normal, we can standardize this. So z is less than or equal to 0.86 minus 0.90 over 0.03. And if you do this calculation, this will be pz less than or equal to, so this was negative 1.33. Okay, so now we have a negative. Last time we had a positive. So instead of using the positive table, we're going to use the negative table here, right? And since we already have that z is less than, then we're good, right? We can use the table right away. Okay, so remember we're trying to find the probability that, let's go back, the probability that z is less than or equal to negative 1.33. So that is negative 1.3 is this, and then 3 over here is this. So we can see that the one we're looking for is 0.0918. So 0.0918. So the probability that our sample proportion is less than or equal to 0.86 is equal to 0.0918. So let's go ahead and conclude this. So conclude. Okay. So there is a 9.18% chance that, let me scoot down a little bit, we would get a sample in which 86% or fewer of the orders were shipped within 3 working days. Okay, so this is telling us that the shipments that have 86 out of 100 or fewer than 86 out of 100, there's a 9.18% chance that that would be the case, right? So let's look at part B. A critic says you claim 90%, but in your sample, the on-time percentage is lower than that. So the 90% claim is wrong. We need to explain in simple language why your probability calculation in A shows that the result of the sample does not refute the 90% claim. Okay, so let's think about this. If the probability that p hat is less than or equal to 0.86 is equal to 0.0918, this means that the probability that p hat is bigger than 0.86. So that means the probability that the proportion of the orders, right, is going to be that they arrive, the proportion of the orders that arrive within 3 days is bigger than 0.86, is 1 minus 0.0918, which is about 0.9082, right? So about 90%. So the probability that proportion is bigger than 0.86 is actually 90%. So it doesn't seem like it refutes it at all, right? So for part B, we could put something like, okay, so this could be part B. We could put if the 90% claim is correct, right? Then we can expect to observe more than 86% of orders shipped on time in about 90.82% of the samples of size 100, right? And I think that answers the question where it does not indicate that they're wrong about their claim, right? Mhm.